This week we're going to get into solving equations that have variables on both sides. As it says here, we have solved a good deal of problems up to this point. First we talked about using the 5 decisions. Remember, the 5 decisions are add, subtract, multiply, divide, with the 5th decision being switch all the signs. We then learned to use distributive property and combine like terms to simplify messy equations, but we have not seen equations with variables on both sides yet, and so that's what we're going to do today. It says equations with variables on both sides pose a different problem. Consider a visual example that I'll show you right now with the problem 3x plus 5 equals 7x minus 2. So again, 3x plus 5 equals 7x minus 2. So let's say that you have this question here. And keep in mind that our overall job is to get x alone. And so what some of us will think is, okay, we have a variable on both sides. If I want this x to be alone, I will simply take the 5 by subtracting it and move it over here. Don't worry about the fact that it's still positive, but just look at the fact that I moved the 5 over here. This x is happy, but this x is now going to say, you just added somebody over here that I don't like, and that's a problem. So going back to 3x plus 5 equals 7x minus 2, what if we said, well, 7x said, you know what, I don't want you around, so I'm going to kick you out and send you over to the other side. 7x is happy, but now notice that 3x has an issue where you just added something else over here that they don't want to deal with. And so when it comes down to variables on both sides, the best way to do it is to say to yourself, first, let's declare a side for our x's. And so we do that by moving one of our x's over, and then after you have a side for your x's, you kick the number out, and now you have your x's on one side, numbers on the other side, and you can solve the way you normally would. So what I'm trying to get you to understand is that we cannot begin to solve any equation until the variable has what I will say is declaring a side. So whether you want to work on the left side or the right side, it does not matter. You just have to actually choose a side to put it on. You just have to use algebra to pick one side. So let's look at an example real fast that is on your notes as I talk through everything that is there. And yes, this writing is small, but it's so that you can kind of read along on your notes anyway. But if you had 5x plus 2 equals 3x minus 8, again, you have to declare a side. And so what we're going to do is say, I'm just going to move this 3x on that side. And the way we send something to the other side, remember, is by sending its opposite. So subtracting 3x from both sides actually cancels those two out. 5x minus 3x gives us 2x plus 2 equals, and don't forget that's a negative 8. Once we get there, that is what we call home, because now we subtract 2 from both sides, which of course makes those two things go away, giving us 2x equals negative 10. The last thing we do is eliminate that by dividing by 2, getting x equals negative 5. And just to show you that it doesn't matter which side we use, I'm going to work the same problem out, or we are going to work the same problem out by moving the 5x instead. So if you look back, what we did here was we moved the 3x to the left side. This time what we're going to do is we're going to actually move the 5x to the right side. And the way you send a whole chunk of information over is again by adding its opposite to both sides. So go ahead and subtract 5x. These two things cancel out, bringing down a 2. 3x minus 5x is negative 2x minus 8. And even though we have a negative x, we're still home because we know that we need to move this 8 by adding it. Getting 10 equals negative 2x. Keep in mind that you need to learn not to multiply or divide by negative, so what we're going to do now is use option number 5, which is to switch signs, and then divide both sides by 2 to get negative 5 for x, which is the same as what we got up there. So again, it does not matter what side you pick, you just want to make sure that you know how to move the numbers. What I usually do is I pick the smaller amount. Again, would it make sense if there are 5 people in one room at a hotel, 3 people in another room? So you're talking about a hotel room. Does it make sense as the hotel manager to ask 5 people to pack up and move into this room, or to ask 3 people to pack up all their stuff and move into this room? Of course, it's easier for 3 people to move than for 5 people to move. That includes negatives, where a negative would probably be the best thing to move, but again, with experience, you'll get all that stuff down and you'll learn what the best choice is. But the main thing is we know how to work with negatives, so we should be okay. So as long as you've learned how to work out the basic two-step equations that I called home, These new problems should be easy for you to understand. Tomorrow what we're going to do is work on problems where there is a variable on both sides, but each side needs to be simplified. But for today, what we want to do is just focus on moving the variables and getting x alone. So that's just the one step you're learning today, is how do I move 3x from the left to the right, or from the right to the left. So before we get to your practice, let's get some notes for you to use as a guide. Here we have 5x minus 1 equals x plus 15. Again, you have 5x's here, 1x there. I think it's easier to move the 1, and so we will move the x by subtracting x. Could we move our 5x over there? Yes, but again, it's easier to move the smaller amount. And so 5x minus x, that's 5 minus 1x, which makes 4x minus 1 equals 15. We are now home. So what that means is we add 1 to both sides, getting 4x equals 16. We divide by 4, getting x equals 4, and we are done with that problem. So it's really not that hard to do. It's just a matter of making sure you understand how to move a variable from one side to the other. It is not the same as pulling the 4 off. This is actually taking the full part and moving it to the other side the way we need to. So looking at example B, we have 3x minus 5 equals 7x plus 11. Again, you got 3x over here, a 7x over there. It makes more sense to move 3 people than 7 people. So we are going to move our 3x by subtracting 3x from both sides. Negative 5 comes down. Let me do that again. Negative 5 comes down. 7x minus 3x is 4x plus 11. Then you subtract 11 from both sides. Negative 5, negative 11 make negative 16. If you don't know that it's supposed to be negative 16, please type that into your calculator and make sure you practice getting that part. And then you divide both sides by 4 here to get negative 4 for x. So the only thing different is moving the variable. As I told you so far, you're going to see home a million times. Once you move the variables onto one side, you're home, and it's an easy question. Very easy question, actually, as long as you've been keeping up with everything. C, 2x plus 4 equals negative 18 minus 9x. Now be careful on these, because what somebody will say is that 9 is bigger than 2, but that is a negative 9 and a positive 2, which means that the negative 9 is actually smaller. So anytime you have a positive and a negative, it makes more sense to move the negative, because notice that I am actually going to add 9x to both sides. Getting 11x plus 4 equals negative 18. Home once again, ready to go. Subtract 4, subtract 4. 11x equals negative 22. Again, if you don't know why it's negative 22, type that in for yourself. Divide by 11. Getting the answer of x equals negative 2. Alright. And then the last one, again, looking at this, negative 3x minus 12. Negative 5 plus x. That looks like a 1 and a 3, so you'd want to probably move the 1, but think about it again, that is a negative 3 and a positive 1. It makes more sense to move the 3. So let's add 3x to both sides, getting negative 12 equals negative 5 plus 4x. Home again, because we've got a number and a variable. And so now we add 5 because 5 is negative. Negative 12 plus 5 is negative 7. Again, if you don't know why, check that out for yourself on your calculator. Divided by 4, and because those don't divide and we don't put decimals, we get negative 7 over 4 equal to your x. So again, be sure to practice well. Many of you did a good job on last week's quiz. I think your class average, minus a couple of people who were not anywhere near up to speed on this, was a 92%, which means that for the most part everybody got an A on average. But it just means that even our low scores weren't that low. I think the low scores were 70s, and that was only a couple of those. So just be sure to remember those steps as we begin to improve our skill in solving. Remember that the answers are on the wall. I'll try to see, depending on how the room is set up, if there can be one up front. But just ask me where they are if you can't locate them. Also remember, you should work the problems out in order. I plan these things a certain way whenever I give them to you, and if you jump around from 1 to 5 to 12 to 20 to back to 3, then you're really not getting everything you should. It doesn't matter whether you finish the worksheet. Remember that it matters that you continue to get better at this skill. So I don't grade your work based off of whether you finish. I actually just give you a quiz at the end of the hour, and try to see what you know. But other than that, like I said, your participation is you working all hour. Now again, you can talk a little bit, but just make sure you're working the whole time that you're doing that. And again, you've been doing a pretty good job, so keep it up and good luck today.